Introduce hybridization, right? So we've got an example here. Garrett. So Hannah, Heather, Jake, focus. So yesterday we introduced this, and we talked about the importance of it as far as modeling. It's kind of like making a plan to build a house. Eastern was built based on a plan. They just didn't get together and say, let's put the library here and then argue about where it's going to be, and then it doesn't get finished. So plans are always done first. And that's the idea behind the molecular geometries. And yesterday we looked at specifically the molecular geometry of mustard gas, because mustard gas was modified to make chemotherapy. They modified the chlorine, I believe, and put nitrogen on it. There's something called nitrogen mustard gas. So if you understand what it looks like, it's a lot easier to then start manipulating the molecule and try to solve problems, some real-world problems that we still have. All right, so up here, the first thing you're going to want to do when you're trying to determine the hybridization, step one, you have to find the Lewis dot structures. This is kind of what we've been doing. And we talked on Monday that the nonmetals have the exceptions. You can see here with the Lewis dot structure, you've got 10 to 12 electrons that can be around some of these nonmetals. But typically we just go with 8. 8's typically the valence outer shell. And you can see that here with CO. Does everybody know what CO is? Carbon monoxide. Now, carbon monoxide is produced by your automobile, Eliza. Carbon monoxide is produced by your automobile. Now the problem is, carbon monoxide, is that good for plants? No, it is not good for plants. It's really bad for the environment. Is it also a greenhouse gas? Not really. Carbon dioxide is really more of a greenhouse gas. The benefit of carbon dioxide is that it allows plants to make it into sugars a lot easier. Plants prefer carbon dioxide. We breathe out carbon dioxide. We don't breathe out carbon monoxide. So automobiles, if you don't have what on your automobile, it will produce the catalytic converter. And what is in the catalytic converter? It's very expensive. It's about $1,500. Platinum. Yeah, platinum is inside. If you look at the muffler, there's no like spinning wheel or little mechanism. It's just platinum metal. And they've been known to be stolen before because it's precious metal. You can melt it down. So the platinum catalyzes the formation of this CO2, which you see right here. Here's your example here. Once again, we have 8 electrons around the carbon and the oxygen. So what are they doing here? Raise your hand. Right, and what are they doing with their electrons? Lauren? Sharing. Yeah, they're sharing. Yeah, that's the important part to understand about the covalent. You see how they're kind of sharing? So this is my wife, and this is her sister, and they're kind of sharing their clothes. Remember that? Yeah, they're sharing their clothes. So, yeah, sharing is an important part. It's going to bond directly to the carbon. All right, very good. So you can see now that the carbon is sharing with the oxygen. Does everybody see that? Let's draw in green so you can visualize it. Does everybody see the sharing happening here? And then you can see the sharing happening here and the sharing happening here. So, sharing. Electrons. Carbon is sp2 because it's got 2 things bonded off to the side, as you can see with our carbon right here. All right, so sp2, and then we have the last one. The book doesn't do a great job explaining this, so we're just trying to look at some of the most common hybridization. So I try to double check myself when I'm doing this. So like when you're in the workplace, you want to do the same thing. You always want to measure twice, cut once. So The sp2 is right here, because you can remember from yesterday the diagram is showing you this 3-leaf clover. So the 3-leaf clover, you can see it right here. So if you put the clover right there, you can see that there's kind of a clover with the dot to the dot and here. So that's showing us sp2. This one in the center, the reason why I checked this, because I was like, this looks really more like sp than it does sp2. And that's true, it is linear, so it is sp. And then our last one here, we just put the diagram, and it's sp2 again. So it's important to know how to use these visuals to help check yourself to make sure you're right. And you always want to check yourself before you then go like purchase and then cut. Because if you're purchasing things you don't need, guess what happens? Companies lay off people. Like yesterday, there was a company, I think in Oklahoma, Chesapeake Energy, laid off 400 people because they purchased things that they didn't need. So when you do this, you need to be really careful about yourself losing your job. That's why you always want to plan and make sure the plans are correct so that people don't get fired. We have a triple bond. So the triple bond, Cody, the triple bond usually tells you have what type of hybridization? The sp. The sp is linear, remember? Now this is the reference, so we're just referring back to our sheet. The triple bond typically tells us sp, but there was an exception here. This is a double bond, right? And this one is sp. You don't see any triple bond here, do you? No. But it's producing a linear structure, the sp. So just be aware that you want to apply to what you're seeing here, right? So this outline shows you this is most similar to sp2. This looks linear. Do you see anything above this carbon? Garrett, you see anything above the carbon?
No.
You see anything below the carbon?
No.
That's why it looks linear. And you know that there are 2, 4, 6, 8 electrons around it, right? You see the 8 electrons here that are being shared? So it's forcing this really to be linear. And you can see that with the sp2, it's using these electrons to give you that shape. Okay? All right, so the last one here, this looks most similar to the sp3 in that you have single bonds, right? And you have 4 of them. 1, 2, 3, 4. So it's sp3 hybridization. It's basically the concept of hybridization was introduced because it was the best explanation for the fact that all 4 of the CH bonds in methane were identical. That's methane right here. So we read about that yesterday. We're just kind of reviewing it again today to reinforce what this was based on. This sp3 hybridization is based on methane. Yeah. Lab. That's a lot. Number 6. Adam.
This is the correct name for the compound FeS. This is C, iron sulfide.
7. Anna.
Which of the following compounds contains lead ion? A. PbO.
Number 8. Jake.
The name of an anion that is part of an acid in the acid name includes the suffix AS.
8 is A. Very good. Number 9. Let's go with Lauren.
In which of the following are the symbols and names for the ion given correctly? I put A.
9 is A. Number 10. Let's go with Cody.
Which of the following shows both the correct formula and the correct name of an acid? I put C, H3PO4, phosphoric acid.
Clayton.
Which is the correct statement of bond strength? That's it. C, compound containing atoms with greater charges than applied bond strength.
Hannah.
What is the formula of hydrosulfuric acid, DH2S?
13. 13, have I got it?
I got it.
Alright, go ahead.
Which is the correct name for the compound NH4SO?
And oxygen sharing electrons came first. Girls sharing dolls, that didn't come first, right? So remember, there's just an analogy here. This is not always true, but it just helps me remember that nonmetals share, right? And sharing is very different than trading. If you trade a baseball card, there's an old saying. What's the old saying?
No trade backs.
Okay, you got the center part right. It is a double bond here. That's correct. But you got to put this is good. So you got 2 from your carbon over here, and you got 2 here. So you got 4 more to place on this and 4 more to place on this. You have to place 4 on the outside. Or 2 pairs of electrons. Yeah. Exactly. So you've got your total of 6 around your oxygen. 2, 4, 6, right? Carbon, 2, 4, and then 2, 4, 6. All right, good job. All right, so once again, we're up here talking about CO2, climate change. Right, you can see that there are 3 variables here. You've got the lone pair here, and the double bond. So you've got 3 locations of activity or electron movement. So that's most similar to the model for the sp2, where you have the x-axis, the px, and the py, symbolic of the sp2. Here you have 2, like you see right here, there's 2 and 2, so that's symbolic of the sp. So we got that linear. This is linear. This would be sp, sp. And then we have their sp2 here are 1, 2, 3, referencing the px and the py. 1 is D. D. Number 2. Read it for us, Luke. D is correct.
D.
4 is C. Hybridization be mathematically proven. Brendan?
No.
No, it cannot. It's just a way of visualizing what's going on with the hydrogen bonds or with bonding in general. So up here, we have our carbon monoxide. Now, carbon monoxide what produces carbon dioxide? Anybody know? What produces it? No, we produce carbon dioxide. Plants can produce carbon dioxide. You know when they do that? Nighttime. That would be respiration. Photosynthesis makes oxygen. Now at nighttime, plants have to survive, so they respire and make CO2. So plants can kill you. They do make CO2. Now we're talking about CO, carbon monoxide. What makes that? And a lot of it. Automobiles. Now that's bad because plants prefer CO2. They don't like CO. They prefer CO2 because CO has this triple bond. And what do you know about triple bonds? They're strong. They're hard to break. Okay, look, good job. So if you take in something, plants don't like it because it's going to take too much energy for them to get the carbon. Plants want carbon. What do they do? What do they want to do with the carbon? They want to make like fruits or, apple trees and pear trees. That's where they store those sugars. So they want to make things with it, the carbon. So they get the carbon out of the atmosphere to make, the branches and the leaves and whatnot. So they want to make things with it. If it's hard to break, they don't like it. So on your automobile, what is on your automobile to help make CO2, carbon dioxide, from the carbon monoxide that's typically made when the engine undergoes combustion? Have you ever heard of a muffler? Now, in the muffler, there's a part called the catalytic converter. You ever heard of the catalytic converter? If you look underneath your car, there's a big part of the muffler. It's kind of encaged in this like metal apparatus. And part of the reason why it's encaged is that people can steal it. It's worth several $1,000s. Why is the catalytic converter worth so much money? Huh? No, because it's got platinum in it. Platinum is a very precious metal, it's very expensive, and it's used to help the CO catalyze the CO into CO2. Now, if your engine light goes on, your oxygen sensor may be out, and the oxygen sensor controls how much oxygen goes into the reaction in your engine, and that can burn up your catalytic converter. So if your oxygen sensor goes out, you're going to want to replace that, because replacing your catalytic converter can cost you, $2,000. Keep that in mind. So once again, the carbon is sp, and so is the oxygen here. They're both sp. Just like you see from mustard gas yesterday, all of the elements in mustard gas are sp3. That's their shape. Their hybridization. And the chlorines on the end are going to be tetrahedral. We left that off yesterday. What's the goal? No, the goal is to get to 8. So if you look right here, you see how there's 2, 4, 6, 8 being shared, and you have 2, 4, 6, 8 being shared. So this carbon is sharing 6 electrons here with the oxygen. These in the middle are being shared. So the goal is for us to get 8 around both. See how there's 8 here and 8 here? So we're trying to do the same here. Now instead of having CO, we have CO2. So we want to organize it to where there are 8 around all 3. The carbon and the 2 oxygens. Put it in blue. No, put it in green, because the oxygens are green. So this oxygen still has 4 more electrons to place, because it's got 4 and 2. Oxygen has 6 around it, 6 valence electrons. So you've got to put 4 more around this one and 4 more around that one. Yeah, they're paired. Now when we write this, they don't typically show it like this. They'll typically show a dot here and a dot here, kind of like they're paired up. Yeah, like that. Because they're going to want to be close to the actual oxygen nucleus. Make sense? Mm-hmm. Now, if you look at this, because of the sharing. Now, you can draw it another way, which we're going to do real quick. We're going to put the oxygen double bonded to the oxygen. This is what this means. These 4 electrons here tell you have a double bond. And then we have our electrons here. So you can see it this way as well. Now I'm drawing it this way so we can determine the hybridizations. What do you think carbon is? Do you think it's sp2, sp, or sp3? Raise your hand. What do you think it is? Does it look linear, or does it look like px, py? Okay. If we look at our sheet from yesterday, right, the one that I gave you that looks like this, does the carbon look like linear px, or correction, sp? Does it look like that? Looks linear to me. Do you see anything above the carbon? No. That would mean it's linear, because there's nothing above it. There's nothing above it or below here, so it's going to be sp, because it's linear. Raise your hand if you don't understand that. Okay, what do you not see here that you think it should be linear, or something other than linear? Linear. That means there's nothing above it or below it. It's just linear. Px, like on the graph, Px. Okay, if that's the easiest one to get, that's why I did it first. If you get any of them, get the Px. That's the simplest. All right, now the next one you can see here from the yesterday's page. It kind of looks like this, and we have this, we have this. So right here is going to be your px, and this is going to be your PY, you see basically two things. And that's what's going on here. You see a direction here and a direction there. You see that? So this is symbolic of the SP2. That's going to be SP2. Like we showed you yesterday on this diagram. So I reference these when I'm trying to do this so that I understand what I am designating. All right, let's do the last one, carbon. Now carbon, you're only going to talk about one, that is the carbon. Okay. Exception to the valence rule. Here, hydrogen is behaving like helium. They are sharing these electrons here. Does everybody understand that? There's a sharing happening here. 6 is C, number 7. Alright, okay.
Which of the following compounds contains the lead 2 ion and I got A?
Number 8. Diana.
What was
What
the
is the name of the formula that is part of the acid
7A.
ions? The acid name includes the suffix
Number
9.
8 is A. Number 9. Lance.
And which of the following are the symbols that gave the ion given correctly? Answer A.
Number 10. Diana.
Which of the following shows both the correct formula and correct name of an acid? C.
Number 11. Harrison.
Which is the correct spelling for of bond strength? I put at C.
Number 12. Number 12 is D. So it's hydrosulfuric acid. And the key there is the hydro, because it's H2S. Whenever you see hydro, that tells you it's going to be like hydrochloric acid. Hydro tells you it's going to be an element.
I thought it was whatever it's called because of the NH.
The hydro is the indicator for an element. So if you see hydro, just remember that, it's an element. And 13. Diana.
What is the correct name for the compound NH4SO4D?
And 14. Gabriel.
With 13 elements, we require which terms in the compound?
And 15. Lily. You get 15?
Oh, I got it right.
Hey, there you go.
Okay. Which is the correct order of bond strength from the greatest to least for the component? Whatever those are. D.
D is correct. You understand why it's D?
No? I got it
Um,
right.
The strongest is going to be the most difficult to break apart, and the weakest is going to be the easiest to break apart. So if you pour bleach on your clothes, they will change them pretty easily because chlorine breaks apart easily. So the chlorine is the actual least strong bonded because it breaks apart easily. That means it's most reactive. If you break apart easily, you're very reactive. Alright, so you're weakly bonded. And 16. Don.
When dissolved in water, acids produce C.
And 17. Kayla.
Wait, I don't think I got 17.
Okay. Anybody got 17? Alright, read for us, Harrison.
How many total electrons must be in order to form one formula unit of the compound? C.
That is correct. Did you get it? That is correct. Do both of them because I want to kind of explain one thing with it. Is looking to gain, or correction, share. It is sharing 4 electrons. So what noble gas is it behaving like?
Helium.
No. Carbon. No. No. What did you say? Neon? Yeah, neon is correct. Who said neon?
I said that
You say neon?
Jacob said it.
You didn't say neon.
Jacob
Yeah, he
said
said neon.
He said neon.
Somebody over there said neon. And I said neon.
Alright, Annette, why are we moving away from coal? Yeah.
It's bad for the environment.
We're running out of it.
We're not running out of it. Why are we moving away from it?
Maybe it's polluting.
What?
It's polluting.
James?
Is it because we're running out of coal, Joe?
No, we're not running out of coal. There's plenty of coal. Listen. Pollution, though.
Is it because it's faster?
No.
It's too hard to mine.
No, you're close. Francesca? No. Well, when you say more effective, that's pretty vague when you say that. There is a lot of truth with methane being more effective. The reason why it's more effective is that you don't have to heat water with it. So you can run methane right into an engine and the engine can turn the turbine. The problem is coal has to do what? Heat water. You have to heat water with it. Water, has a very high specific heat. What does that mean?
Oh, it takes a while for it to boil.
Yes, it takes a while for it to boil. So you're wasting a lot of energy heating water. And we want to get away from that. We don't want to heat water. So most of your coal plants will probably be replaced within the next, let's say, 50 to 100 years because we don't want to heat water. We want to generate electricity directly. And 34. Let's go with Naomi.
Which of the following is true about the composition of ionic compounds? I put A.
And 35. Rosebud.
Which of the following compounds contains the Na3 plus ion? I said C.
35 is C. 36. Isabel.
What is the correct name for the compound PCI5? And I put C.
And 37.
What's 36? Ariel. C.
37. Ariel.
What is the correct name of compound N2O3D?
And 38.
Sorry. What was it? D or C?
It's D. 38. Annette.
Please stop. What is the correct name for the compound COCO3? It's B, cobalt carbonate.
And 39. Andrew.
Which is the correct name for the compound CaClO2? I put C, calcium chloride.
40. Okay.
What'd you say, me?
Which is the correct name for the compound HClO3, chloric acid? B.
41. George.
A formula unit of calcium bromide has 2 bromide ions corresponding to each calcium ion in the compound. What is the formula of calcium bromide? I got B.
42. Naomi.
Sulfur hexafluoride is an example of C, binary compound.
And 43. No, we got 5 minutes. 43.
We got 2 minutes.
Consider a methane
43.
compound having the formula MT if the compound is not acid if it contains only 2 elements.
Hello, camera.
And if M is not a metal, which of the following is true about the compound?
And 44. Rasante. D. D. And 45. The converter. Raise your hand if you ever heard of catalytic converter. It's part of your muffler. What's in the catalytic converter? Sean, what's in the catalytic converter? It's a metal. What metal's in there?
Carbon.
No. Raise your hand.
Oxygen.
Copper.
No.
Silver.
Oxygen.
No.
There's no metal.
Raise your hand.
There's a non-metal.
Magnesium.
I'll tell you it's a precious metal.
Gold.
Copper.
No. No.
Silver.
No.
Aluminum.
It's more precious than silver. Platinum. So, yeah, there's platinum.
Yes, come through.
If you price catalytic converters, they're anywhere from $1,000 to $1,500 because of the platinum inside it. People will cut them off. People will crawl underneath cars and cut them off. If you see somebody, you know, that's had their catalytic converter stolen, you'll now understand the platinum was the reason.
And around the accident.
I want a total of 8 around all 3 of them.
Let's see.
You see right here? See how I have 8 around this one? 8 around this one? You're trying to do the same thing here.
Yeah, I got you.
I'm not giving up. I didn't get my stuff.
Josh, you can do.
So you've got your first part, but you need to remember there are 6 electrons around oxygen. He only has 4 shown. You only have 4 shown here. So you're halfway there. B is correct. 28. Giovanni. 29. Ethan.
Oh, wait.
Say 29 says a compound has the formula X cubed Y, where every 15 X atoms present in this compound, how many Y atoms are there? So what is 5 times 3? So what must Y be? Right, it must be 5. And 30? Ethan?
Which of the following correctly provides the name of the element, the symbol for the ion, and the name of the ion? I said C.
31. Josh?
What is the name of H2SO3? And I said D.
32. Giovanni?
Which is the correct name for the compound HNO2? And I got C.
33. Ethan?
I said, what is the formula for phosphoric acid? I said B.
34. Noah? You may read it for us. Here you go. Yeah, you want to, reading aloud can sometimes help you learn and memorize things. It's